So let's start on with a very simple question, and you have a question like int sol, and you will be having x, and you will be having y. Okay, so you need to set the xth and the yth bit of a number and return the number itself. Okay, that means that currently you don't have any number. You just have to return a number whose xth bit and yth bit has been set. Are you guys getting it?
No, the last word was not
Just give
clear.
me a minute. Yes, so my last sentence was that if I'm saying that, okay, your x is 3 and your y is 5, then you need to set your number as this is your fifth bit, this is your third bit, and this is how your number is look like. That is, you are gonna get 40. Like if I converted it to a decimal number. How come xth bit and yth bit is null? They are numbers, not some objects.
Ma'am, if I'm correct, 3 is represented as 0, 1, 1.
Huh? Sorry. I
Oh,
am not saying that you have to represent 3 in a number.
okay. 35
What
you have to.
what I am trying to say here is third bit of a number. That is, this is your 0th bit, first bit, second bit, third bit. So third bit should be made as 1. Set bit means it should be having the value as 1. Unset bit means it should be having the value as 0. So I set my fifth bit as 1. That means I set the fifth bit, and same goes with the third bit.
Okay, now I'm clear.
Okay, so you guys know that when we do the right shift, sorry, left shift operator, it's like move shifts the digit from its current place to whatever right shift we want to do. So if I do one right shift X, it is gonna shift my one X times. Same goes with Y. If I shift my one Y times, it's gonna shift my one Y times. Getting this? But the problem here in this particular solution comes when X is equal Y. Okay, in that case, what will happen if let's suppose I said third and third bit you have to set. So what I did, I just set up the third bit for X. I set up the third bit for Y. When I will do add means it's basically OR operator. Sorry, not the OR operator. It is just a minute. Yeah, when I'm adding these numbers in decimal, when you add the numbers 1 plus 1, it gives you 10. That means here it will be 0, 0, 0. This will be 10. So 1 will be carried forward, 1 and 0. And this should not be your answer. Your answer should be like only this much, even if the two bits are getting set. Are you guys able to follow? So in this case,
It's a kind of an OR operator. Like
n-
uh, by OR meaning if both 1 and 1 are there.
no, it's not an
Mm,
OR operator. it is a proper addition. There is a bitwise addition happens. Okay. And when you do bitwise addition, 1 plus 1 is 10. Okay. It's not 2 in bit. It's 1 plus 1. It makes you 1 and 0. So here it will give you 0 and 1 carried forward. It will give you 1. We do not want it. Hence, instead of addition, we just apply here OR. When you do OR, you know that if it is 1 and 1, it is going to return you the value as 1. Clear? So this problem name was set xth and yth bit. Clear, guys? Okay. Now you have been given a particular number. The other question is, you have been given a certain number n, and you have to check if its ith, check if its ith bit is set or not. Okay, that is the question. Ith bit means you will be given the input as Boolean, check bit. You will be given the number n, and you will be given the number I. I is the ith bit, and you need to check it. Can you guys do that? Or at least try doing that? Okay. Any suggestions or ideas how you're going to do that?
So what I'm going to do is, if there are like 7, so 4 plus 2 plus 1, and I'm just asked to,
Once. What are you saying? 7.
so let's say
So,
1 1 1,
hmm,
and I'm asked I as let's say 2,
okay.
then uh, I'll return true.
How?
Yeah. So let reverse. I mean, first I will convert the n into boolean, sorry, bit, uh, by dividing by 2.
You need not do that. It's it's a very big solution. The simple thing is, you can simply do the right shift on n for I times. If you do the right shift of n for I times, your whatever bit is there, it will reach the end. Yes or no? If you do the right shift on n I times, it will reach the ending number or ending bit. If you do AND on it, if the number was 1 or if the bit was set, it is going to return you 1 only. That means the bit was set. Yes or no?
Yeah.
And if by any case this was 0, it is going to return you false. That means your bit is unset. Clear? Instead of this, you can also do n, right shift I. So again, it will like take your bit to the last. You can do modulus 2. So if it would have been odd, then it will return 1. 1 means true. If it would have been even, then it will return 0, which means the bit is not set. It's an unset bit. These are very simple questions in bit, and they are very useful because they are like sub parts of the main or big questions in the bitwise manipulation. So all those who study bitwise, they should know these basic questions. Okay. The next question could be count the number of set bits. That means if your number is, let's suppose, 15, so 15 is gonna contain 1, 1, 1, 1, 4 times. So this has 4 set bits, so you need to return 4. Let's suppose your number is 6, it is 110. So this particular should return, like this should return 4 as an answer, this should return 2 as an answer. So this is your question, that you have to find out how many number of bits are set in a particular number and how many number of bits are unset. Clear? Okay, if the question is clear and you guys know how to check if the bit is set or not, can you guys do this? How? How you are gonna do this particular question? You can give me the idea which you are having and it will be good. No responses, guys. Can I assume you will do this question on your own?
So, ma'am, this can be done in recursion also, but I can use iterative like while n equal to 0, and then in the outside I'll have a temp variable, and inside I'll keep incrementing with every shift operator. Uh, Single right shift will will check
Why single right shift?
so that we don't skip one any one digit, like oh, okay, uh, uh, like or I think two digit, two right shift, so that we want to know that that value is 1 or 0, and if it is ampersand 1, then we increment the counter temp by 1, otherwise we will return
First
in
is while it's not while n equal 0, it's like while n not equals to 0, right? Because if
okay.
n is not equal to 0, then only you can proceed. If your n is equal 0, that means you need not calculate anything. Then you can have a count variable outside in c equals to 0. Every time you need to count when your bit is set, right? So c equals to c plus, and what you need to do, you need to do n and 1. So when you will do this, you will get to know that whether your last bit is set or not, because when you do and with n, if the bit is set, you get 1 as your answer. If the bit is unset, you get 0 as your answer. So you will do this. And after this, every time once you have calculated the last bit, you're going to shift it towards the right, the remaining bits. So n will be equals to n right shift 1. This is how your every bit will be calculated. At the end, when it's 0, then you are going to return C.
Count C.
Yeah, clear? Good try, Vishnu. Other than that, I will just explain you like verbally. There are total 31 bits in a number if it is an integer number, and otherwise, if it is a long number, there are 63 bits. So you guys can run a loop for 31 times or 63 times depending on the number. And then every time you can just apply your check bit function and check if check bit n comma I will be your bit. And when you will be done like checking for all the bits, then no bit will be left out and you will get your answer. So that is an, like you can say, numerative approach, and this is more like an, you can say, depending on the n approach. Clear?
No, what is, I mean, I didn't get that word, check bit operator.
Check bit operator I just explained, right? Where you have to check whether the specific bit is set or not previous to this particular function.
Okay, n ampersand I. N,
You have some doubt?
no, check bit operator, I'm just looking at the past one.
Yeah. Okay, so we are done with the basic questions of bitwise manipulation. Now I'm gonna give you a question that is repeated elements. It is one of the very classic problem, not that much hectic, but yeah, it's just the trick which I want to know from you all. So there is this particular question where almost every number, like all the numbers which are there in the array are repeated once, except one number, okay? Like there will be at least one digit in this entire array which is not repeated, and you need to identify what is that number. So according to this particular array, the answer should be 7. Clear, guys, the question? Yes, okay. How can we do that? Do this if all the numbers are repeated twice except one number? Obviously, we need bitwise. Otherwise, we all know that how to calculate. We can just put them in a set, find out the frequency. The number with one frequency is like, okay, that is our answer. Why you want to create array of bits?
Oh, to put them all in the array and then apply those operators to see if it is 100% match or.
No. You guys know, right? If same numbers are odd or we do or XOR on two similar numbers, what we get? Yes, no? Forgot. Wow. When we do XOR on two similar number, you get 0. So if I apply XOR on all the numbers in this specific array, same numbers will give 0. So this and this cancelled out, this and this cancelled out, 1 and 1 cancelled out, 12 and 12 cancelled out, and only 7 will be remaining along with XOR 0. And when you do 7 XOR 0 or any number XOR 0, you're going to get the same number. So you will get the number which is not repeated.
Ma'am, I wanted to know, like in one line, in a one while loop, can we just put all the numbers with XOR, 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 XOR?
Yeah.
Mm, all works in one shot,
Yep.
and it returns me 7.
Yeah. It returns you 7.
Okay.
Okay.
Yeah.
Perfect. So the next question is, you have to find out a power n. I gave you all this as an homework yesterday, but you were not able to do it, obviously. Yeah. Can you think it in some bitwise way? How can we do it? Yes, no. So basically, you can think of n basically as x1 plus x2 plus x3 plus so on, and we will assume that their addition is equals to n. So I can write it as a x1 multiplied by a x2 multiplied by a x3 and so on. So, and yes, here whatever your x1, x2, x3 are, they are unique. So if I take the number as, let's suppose, a to the power 22, I can split it as a bitwise, that is a to the power 16 multiplied by a to the power of 4 multiplied by a to the power of 2. Are you getting it? Yes. And hence, we can, after splitting this, we can calculate our answer. How we can calculate our answer, that you guys need to tell me. At least you can participate a little bit in the discussion. So basically it is like, let's suppose I'm taking another example. Let's
Ma'am,
suppose,
ma'am, since you asked for participation, one thing I was thinking that either it could be odd or even, and then that many times, uh, odd or even, that many times we'll do that operator. How we calculate for the squaring of a number, the same thing we'll do for that many times.
yeah. So if it is 13, it is odd. Its representation is 1101. And the bits, like basically here it is 1, this is 2, this is 4, and this is 8. I'm talking about the decimal value of that specific bit place. So if your bit is 0, your x, since it is set, it is going to give x is a, and your answer for this particular bit is going to be a. Your first bit is unset. Since it is unset, here it is gone, here it should be a square, that is doubled. But should it be multiplied to your answer? No. So it will only remain as A. This is reflecting in your answer, but this will not reflect because it is unset. After this second bit, it will make as A to the power 4. And now, should this A to the power 4 be included to your answer? Yes. So your previous answer was A. Now it's going to become A to the power 5. Is your third bit set? Yes. So this is going to be A to the power 8. And now should this be included to your answer? Yes. So it's going to be A to the power of 30. This is how you need to calculate. That is, every time you're updating your value of A, that is, whatever your previous A value was, you're multiplying the same this time as well. That is, if previous was A, now you're multiplying it as A into A. If previously was A square, then you're multiplying as A square multiplied by A square. If it was A to the power of 4, then you are multiplying as A to the power of 4 multiplied by A to the power of 4. This is how you are calculating your values. If and like when you have to include that particular value in your answer only if that bit is set. If the bit is unset, then you need not calculate, like need not take into consideration for your answer. Clear, guys?
No, ma'am, one thing is not clear. Like, I'm a little confused on one thing. When we are doing like A13, so the index starts from 1, or does it start from 0?
Index starts from 0 only, right? 0th bit, first bit, second bit, and third bit.
Okay, 0.
Hello.
Yeah, I'm still thinking. So if it is like in second index, if it is A4, uh, then you're adding it up.
I am multiplying A to the power of 4 with A to the power of 4.
Okay. So it will translate into like 2, it gives me 2 to the power 4, which is no, no, 2 to the power 0. Sorry. Okay, I'm clear now. So the starting point was the problem when we
Now it
put,
is clear.
yeah.
Okay, so guys, you have to implement this on your own. I'm not going to tell you. You all know how to find the set bit and unset bit. You guys know how to multiply the values and all. So I just leave this question up to you. You can do it. Okay. Should I take one more question for the day? Because I've already explained a lot of question for the day. So if you guys are saturated, we can take it up on Monday. Otherwise, if you want, I can give you one more homework. Okay. So the next question is triple trouble. So in this, you have been given an array of n numbers. The numbers are like basically repeated 3 times, except one number. All the numbers you will see it's repeated 3 times, except one number. And you need to find out that specific number from this particular array using bitwise manipulation. Okay. Is the question clear? No response. Okay. So if you want to discuss around this question, we can discuss in the remaining time. I am not going to give you more question than this because it will be too much hectic. And only there are a few questions left now. I can say two, most probably two questions in the bitwise. So we will discuss that on Monday. And yeah, then I guess we'll be done with bitwise manipulation and I'll start try for some time. Then we will take few miscellaneous questions in the next week and we will be done.
So in order to solve this question, uh, can we apply within brackets multiple XORs, like XOR within a XOR? Like
But still, it's not gonna do that much of a help. If you do 3 XOR 3, it's gonna give you 0. But when you do XOR with another 3, it's gonna give you 3 only. So it's not gonna help.
so I'm just thinking that in one cycle we'll apply one XOR, in second cycle we'll apply the second XOR.
But how does it help? If you apply one XOR only, your numbers is gonna get cancelled out. So in the second XOR, you are not gonna get the repeated numbers again. It will be all unique numbers. How you are gonna identify which unique number is you are looking for?
Got it.
Don't worry about this particular question. I'm gonna explain it to you. It's a it's a very important question, and it is in fact being asked in the interview as well. So yeah, I'll explain it. So I'll just close the call for today. And if you guys have any concerns regarding the course since it's getting ended, or any other questions regarding this course, you can just ask me, or any specific topic you want, like, okay ma'am, if you are discussing the miscellaneous questions, this topic you should pick up, and this topic you have not taken much questions on, I will prepare accordingly. So you guys can tell me that now.
Ma'am, dynamic programming for me is
Dynamic programming, I guess I have covered so many questions. So now it's all on your
play.
practice. It depends, right?
Ma'am, is there a way to like just Telegram is the way to get the support?
Yeah. Telegram channel will be active for all time.
Okay.
Yes, guys, any other question? Okay, so if you do not get Telegram. See, it's basically like even I am busy with my work, so probably the response will be a bit delayed, but you will definitely get it, most probably. So need not worry about that. And Ashish, Kishan, Mani, Sai, do you guys have any concerns? You can say because you guys are very, very less responsive in the class. Okay, so if no response,
Ma'am, I know that like you suggested one time that like to get into the habit of practice, you start teaching. But before getting into the teaching, is there any kind of a like a suggestion, like some administrative task where we can just be a volunteer there and then help out in making some material or uh, any kind of support.
Maybe you can be mentors in Ashok IT or probably somewhere else where a teacher is teaching, but you guys are just listening to the class for some time, and when students have any doubt, you can take up the questions. So that, as you were saying, that the Telegram responses, it would be better if you guys are mentors for that. So, like, you will handle the doubts more earlier than the teacher itself, because obviously because of the work.
Okay, so for whom to contact to become a mentor?
Probably Ashok sir, if you want to be the mentor in Ashok IT.
Okay, fine. Yeah, thank you.
Yeah. Okay, then, guys, thank you for attending the session today. I'll see you guys on Monday. Bye bye, and have a good day.